2. Now we're going to talk about subsets. So hopefully you watched 2.1 so you know what a set is. A subset is a smaller group of a set. Sorry, I thought I heard my cat. So a subset of B means all A in A are also in B. So everything in set A is also in set B. And how are we going to write this? So let's say 2, 3, 4. And set B is, we're going to make this real exciting, 1, 2, 3, 4. And then clearly everything in set A is in set B. So we can say A is a subset of B. But B is not a subset of A because B has a 1 and A doesn't. So, whoops, we would say B is not a subset of A. And most of the time, that's going to be a case. We'll have one as the subset of the other, but it doesn't go the other direction. We also have something called a proper subset. So basically, A and B are proper subsets. So we'd say A, there's no bar at the bottom. So A is a proper subset of B if A is a subset of B, but A does not equal B. I'm going to be honest, most of the time we don't use the proper subset. When you get into way higher math, occasionally they'll differentiate between the two, but most of the time the regular subset is what we're going to use. Excuse me. So be careful. If we want to say 2, 3 is a subset of A, that is fine. We can list our items. We need to put them in brackets, but you cannot say 3 is a subset of A because 3 is not a set, 3 is an element. So don't do that. Big cross out. So let me write this. Set element. Elements cannot be subsets. We have to put them in the set notation for that to work. Another thing to note, if you recall, we have the empty set is equal to the subset with nothing in there, or the set with nothing in there. So we don't want to put the empty set sorry, my screen likes to fly away. Don't do that. The empty set is the one the one thing you don't put in the subset symbols. It does mean a subset with no exception. That's the word. It's the exception to this. So we would just say empty set is a subset of A. Then for any set, B is a subset of itself, and the empty set is a subset of B. So we're always guaranteed the set itself is a subset and the empty set. Sorry. My screen is being very touchy today. Okay. This section's very short. So the last thing in here is the number of subsets. Whoops. So if you think about a set with a few elements in there. How many different ways can we have unique subsets? So we can make a different set of these objects where they're not the same. Maybe they have the same number, but they don't look exactly the same. If we want to figure out how many, we could do that. So say our set has m elements. So if you make that a little bit bigger. So if you recall from 2.1, n of b means the number of elements in set B. We have 2 to the m unique subsets of if you want to play with this, start with a very tiny set. So we have 2 elements. How many unique subsets can we create? Well, I can have just one element in 2 different ways. I can have 2 elements in one way, very messy too, or I could have 0 elements. So this is 4, which is 2 squared. We could do the same thing with 3. I'm not going to go up to 4. This takes forever if we do that. So we can have each element alone. We can have all of our pairs, AB, AC, AC. We could have our trio. And then we can have nothing. So that should give me 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 8, which is 2 to the third. If you want to check the fourth, feel free. We should get 16, but each time it'll double. So that's how we figure out how many subsets. For us, this isn't super useful, but if you go on in math, subsets are the very basic concept of math, especially higher math. So if you want to go on, you may need to know that. So it's useful information. Okay, that is the end of 2.2. I will see you in 2.3.